Hi, and welcome back to CompTIA Network Plus Lab Series Network Concepts for Lab 6 Network Management. We're going through Lesson 1, Analyze CPU and Network Utilization with Performance Monitor. Performance Monitor is a resource monitoring tool included in Windows-based operating system. It provides utilization information on an expansive list of resources, including but not limited to processor, memory, and network interfaces. Performance Monitor is also capable of monitoring granular aspects of resources that are beyond the scope of this lab, such as IPv4 and IPv6 traffic, hard disk activity, IPsec, and more. In this task, we will open the Performance Monitor to use it to monitor CPU, processor, and network utilization. The first step is to use the instructions in the lab settings section to log into the Windows 2K8 R2 Internal 1 machine. If you're not already logged in, I did before the lab started. So I'm going to go ahead and click on that virtual machine and then get out of the server manager. And then step 2 is to click on the start button and type in perfmon, which is short for Performance Monitor. On to step 3, the Performance Monitor window will open, and under Monitoring Tools on the left, click on Performance Monitor, which is available here. And we can see it starting to run. Monitoring CPU utilization. Currently, the only counter that is being monitored is the percent processor time counter, which shows processor utilization. The x-axis across the bottom indicates the time, and the y-axis shown vertically on the left represents percentage of usage from 0 to 100%. You may notice little to no activity in the graph while the machine is sitting idle. When idling, we can use information about resource utilization to establish a baseline. The counter is also available here, where it shows you that it's percentage processor. In order to see activity on our graph, we will need to generate a workload for the processor. Give it something to do. We will use the disk defragmenter to generate this workload. Click the Start button and type defrag. Click Disk Defragment to open the program. The disk defragmenter will open. Click Analyze Disk, then immediately return to the Performance Monitor to see the effect on the CPU utilization. So I'm going to go ahead and bring this down a little so that you can see it both in the same screen. And I'm going to hit Analyze Disk. And we can see this huge spike over here on the left-hand side where it's starting to do the defragmentation. As you can see, the last run says running as it's processing, and now it's done. The graph shows the effect that analyzing the hard drive with disk defragmenter had on CPU utilization. Although the spike in utilization was relatively short-lived, the user may have noticed that other processes or programs on the system would have been affected by the spike in CPU activity. A user may notice slower internet browsing, jerky video playback, and slower system responsiveness in general when the CPU utilization is at 100%. When compared, the graphs should show significant differences. Having the baseline graph of what a machine processor usage looks like when the system is idle allows the user to compare results while the system is in use and determine normal or abnormal system behavior. Lesson 1.2, Monitoring Network Utilization by Adding a Counter. The Performance Monitor can be used to monitor network activity as well. In this section, We will add a counter for bytes received in the performance monitor utility, then generate traffic and use the graph to observe the resource usage of the system for bytes received. Right-click anywhere or inside or close to the graph in the performance monitor and select Remove All Counters. So I'm going to close this first and then right-click and select Remove All Counters right here at the bottom of our drop-down. This will remove the percent processor time counter from the performance monitor. When asked if you are sure you want to remove all, add counters and click OK. Right-click in the same area again and select Add Counters. To open the Add Counters dialog window, the Add Counters window will open. From the list of available counters, locate Network Interface. So I'm just going to scroll up a little here because we're in the P's, so it looks like it's in alphabetical order. Here's Network Interface. And expand the category by clicking the plus sign next to it, which is here to the right. From the sublist, select bytes received per second. Then from the list below, titled Instances of Selected Object, select Intel R Pro _1000 MT network connection and click the Add button. So we are looking for the first one on top of the list, Intel R Pro _1000 MT network connection, and the Add button is right below this field. I'm going to hit Add and then click OK, because this entry should be it. The new counter for bytes received per second should appear in the counter table underneath the graph. The graph will show little to no activity until we generate some network activity. To generate data on the network, we will execute a flood ping from another system. So click on Backtrack 5 internal icon on the topology. So I'm going to go ahead and select the topology tab on top of the lab window. And then the third to the right side of the screen here is the Backtrack 5 internal device. I'm going to click on this topology because it's interactive, and it will take me to the Backtrack 5 internal screen. Now I've already logged into this, so we're already at the start of the screen. And in the instructions, it'll tell you and walk you through that. At this point, we are at step 8. Click the icon to the right of the system menu to launch the terminal window, which is here on the top left corner of the screen on the menu. And then execute a ping flood by entering the following command, which is hping3 space -- flood FOLOOD space 192.168.12.10, which should be the IP address to the W2K8R2 internal 1 machine. And I'm going to hit enter to execute that. We should get a message that says HPing in flood mode, no replies will be shown. In step 10, it says return to Windows 2K8R2 internal 1 machine and notice that the reading on the graph quickly disappears to the top of the screen. So back at the internal 1, and they are absolutely right, it's way at the top. The graph disappears to the top because the y-axis only registers up to 100. We will either need to increase the y-axis or change the scale of the counter to be able to see it on the chart. Right-click anywhere on the graph and select Properties from the menu. So again, we're going to right-click inside of it, Properties is on the bottom of the drop-down. We were going to select that. And in step 12, it says from the Properties window, click the drop-down box next to Scale and select 0.000001 from the list and click OK. So if we go down to the Scale field, we're going to see 5 zeros and a 1. That's 4. That's 5 zeros and a 1. That's close to the course selection from the top. And then I'm going to hit OK. Immediately, you should see the bytes received registered within the graph range as shown below. So now you should see down here on Scale, it should match. There you are. Lesson 1.3, Using the Resource Monitor. The Resource Monitor found within the Performance Monitor can provide a quick and detailed overview of system resources, including CPU, memory, disk, and network. Some may find the Resource Monitor to be more user-friendly interface and display when monitoring system resources. This task will cover how to access the Resource Monitor and view network utilization. From the Performance Monitor, right-click Monitoring Tools in the menu on the left side of the screen and select Resource Monitor. The Resource Monitor window will appear. The Overview tab should be the default tab displayed on your screen when Resource Monitor opens. If not, select the Overview tab. The Overview tab in the Resource Monitor provides a summary on 4 major system resources: CPU, disk, network, and memory. Each resource can be expanded to show which processes are responsible for resource utilization. A graph for each of the resources appears on the right. Click the Network tab. The Network tab provides detailed information on network utilization. Details on processes that are using network resources such as process ID, PID, remote IP addresses, IPv and IPv6, bytes sent, bytes received, protocols in use, ports listening for connection, and the firewall status of those ports allowed or blocked are provided. Explore the various tabs in Resource Monitor and notice in each tab the list of processes that are being monitored. Placing a check in the box next to the processes follows the monitor to filter based on one or more of the running processes selected. For troubleshooting, this makes it easier to focus on tracking processes that could be causing issues and help with the problem solving. At the moment, it seems the screen isn't working. Let's see if we can end this and then restart the flood. hping 3 flood 192.168.12.10. Hit enter, go back and check out and see if there's any network activity that pops up. There we go. So as it was saying, you can select one of these here and it will filter it. Now we're going to close all open windows and stay logged in to continue to the next section of the lab. Which should bring us to the conclusion. And in the conclusion, the Performance Monitor provides a wealth of information on system resources and can be used as a troubleshooting tool by network technicians. Technicians can create a custom graph to monitor select system resources by adding counters for those resources. The Resource Monitor provides similar information, but is already set up to show resource utilization for 4 major system resources: CPU, memory, disk, and network, and requires no customization. The Resource Monitor provides a quick overview of those 4 system resources and details on which processes are responsible for resource utilization. Review questions. What program provides an overview of 4 major system resources? That would be the Resource Monitor. Question 2. In the Performance Monitor, what can you change in the reading of the graph? On the graph is too high to display within the graph window. You would have to scale the counter. Well, thanks again for joining for Lesson 1. Join back for Lesson 2.